Welcome back to another session. So this is the continuation of previous session. So we have been solving exercise 8.1, right? Let's continue the session. So this is the sixth problem. If angle A and angle B are acute angles such that cos A equal cos B, then show that angle A equal angle B. Actually, one figure is given in your book. So this is what the figure. So let's see here what is mentioned. So angle A and angle B. These two angles are acute angles. So what are acute angles? The angles less than 90 degree called acute angles. Okay, coming back to our question. So these two angles are acute angles, and same time another one proof is given, cos A equal cos B. If this is the case, we have to prove angle A equal angle B. To start the solution, let me take the given proof. What is the cos A equal cos B? Okay, I write it the same one, cos A equal cos B, and let's see how it benefits us. So what are the values we can obtain from this? So we know that cos theta is, which is cos A is, so the ratio of cos theta is adjacent by hypotenuse, which means, so here is the A angle, so sorry, theta is A here, okay. So you have to write the ratios according to this theta A, okay. So here what is the adjacent side? AC. So what is the hypotenuse? AB. So here AC by AB. This is for cos A. What is for cos B? Now the theta turn into B. So this time adjacent side is BC by hypotenuse is same AB. Now I equate these two, AC by AB equal BC by AB, because cos A equal cos B, right? Then AB and AB cancel out. So remaining is AC equal BC. So what we got? AC equal BC. So this part and this part is equal, which means the angle, it makes angle A equal angle B or equal. The reason is the angles opposite to the equal sides of triangle are equal. So this is one proof. Let's move on to the next question. Seventh one. If cot theta equals 7 by 8, evaluate the first question, 1 plus sin theta into 1 minus sin theta, 1 plus cos theta into 1 minus cos theta. And the second question, cos square theta. First of all, to start the solution, I write the given data, the cot theta. So cot theta equals 7 by 8. We have two values, right? In a right angle triangle, we know two values, 7 and 8. So what are these two values? So cot theta, we know that it's a reciprocal of tan theta. So tan theta is opposite by adjacent. So obviously cot theta is adjacent by opposite side. So if theta, I consider the theta here. So adjacent side, this must be 7, and the opposite side, this is 8, must be 8. So I am going to name this as A, B, C. So let's next what we do, let's find out the other third side using the Pythagoras theorem, right? So AC square equal AB square plus BC square. For AB square 8 square plus for B square BC square 7 square, 64 plus 7 7s are 49. So the total is 113. This is for AC square. So for AC I take square root of this one. We cannot take anything out. So I write root 113 for AC. The next step what we do, so before that I write the value for AC in the picture. So next step, let's find out the sin theta and cos theta. So what is for sin theta? Opposite by hypotenuse, which is 8 by 7, sorry 8 by root 113. For cos theta, adjacent by hypotenuse, so 7 by root 113. Let's substitute the value sin theta and cos theta in our questions. So 1 plus for sin theta 8 by root 113 into and 1 minus 8 by root 113, this is for numerator. So make sure the equal should be middle. So divide by, now denominator. So for cos theta 7 by root 113 into 1 minus 7 by root 113. So look at here, this will, it seems to need a long calculation, right? So here what I am going to do is, to make it short I am going to use the formula. So look at here, this, consider this is a plus b and this is a minus b. So if a plus b into a minus b, the formula is a square minus b square. So same to the denominator also. So here also a plus b and a minus b gives me a square minus b square. So what I am going to do, I am going to rub this. Let's try the reduced form first. So for example here 1 plus sin theta 1 minus sin theta, what will come? 1 minus sin square theta. Here for a square 1 square, right? So I am writing here. So 1 square minus sin square theta. This is for numerator. So 1 square minus cos square theta. This is for denominator. So we can write this as 1 minus sin square theta and 1 minus cos square theta. Now let's substitute the value for sin and cos. So 1 minus, let me take the next page for 1 minus sin square theta. Okay, so equals 1 minus for sin square theta 8 by root 113 the whole square, and next on the denominator 1 minus 7 by root 113 the whole square, which is equal, let's do it in the next step, 1 minus 64 by, so root and square root will cancel out. So you can write 113 directly. So divide by 1 minus 7 sevens are 49, divide by 113. So look at here, this part I take the LCM. So what is the common denominator? 113. So here I multiply with 113. Here I multiply with 1 by 1. 64. This is on the numerator. So bottom same 113 as a LCM. So here I multiply by 113. So here by 1. So what will happen? So 113 minus 49. So next step, so 113 minus 64 is 49 by 113 whole divide by, so here 64 by 113. So 49 by 113, this part if go to the up will go as reciprocal. So 113 by 64. So these two cancel out, the remaining is 49 by 64. So second question is cot square theta. So cot square theta means it's nothing but, see both are same, cot theta the whole square. So both are same, I just write 7 by, for cot theta is given 7 by 8. I simply take the square of 7 by 8. So 49 by 64. Okay, let me move on to the 8th question. If 3 cot A equal 4, check whether 1 minus tan square a by 1 plus tan square a equal cos square a minus sin square a or not. So, this is also same as previous one. So, to start the solution, I start with the given data. So, which is 3 cot a equal 4. So, we can write this as, so if 3 comes to the other side, it will go as division, right. So, 4 by 3. So, cot theta is nothing but adjacent by opposite side. So, let me draw one triangle. Let us name as ABC. So, this must be 90 degree, and for cot A, so this is the angle A. So, the adjacent side is 4 here and the opposite side this is BC. So, 3. So, to find AC, what will you do? Using the Pythagoras theorem, AC square equal AB square plus BC square. So, we got 5 for AC after substituting the values. Then what are the ratios we need? See, cos, sin, tan, everything we need. Let us find out first. Sin A equal opposite by hypotenuse. So, 3 by 5 for sin A. So, for cos A, adjacent by hypotenuse, so 4 by 5. For tan A, sin by cos, so 3 by 4. Now, we found out all the 3 values, what are the values we needed. Then substitute the value individually on both sides, LHS and RHS, and checking whether these two are equal or not. So, first let me take the LHS left hand side. So, which is 1 minus tan square A by 1 plus tan square A. So, 1 minus 3 by 4 the whole square by 1 plus 3 by 4 the whole square. So, 1 minus 3 3s are 9 by 16. So, 1 plus 9 by 16. Next step, take LCM. So, 16. So, 16 minus 9 divide by here also 16. 16 plus 9. So, top 7 by 16, in the bottom 25 by 16. So, the bottom one will go as reciprocal. So, 7 by 16 into 16 by 25. I cancel out these two. So, 7 by 25 is the answer. So, this is for left hand side. Next, take the right hand side, which is cos square A minus sin square A. Let us substitute the value. So, for the cos A we have 4 by 5, right. So, 4 by 5 the whole square. For sin square A, 3 by 5 the whole square. So, 16 by 25 minus 9 by 25. I hope you got the answer. So, 25, 16 minus 9 is 7. This is RHS. So, both are equal. Left hand side and left hand side and right hand side are equal. So, let us start the 9th problem. In triangle ABC, right angled at B, if tan A equal 1 by root 3, find the value of sin A cos C plus cos A sin C. So, this is the first question. So, second question, cos A cos C minus sin A sin C. So, this is also another easiest problem. To start the solutions, let us start with the given data. So, tan A equal 1 by root 3. So, tan A is nothing but opposite by hypotenuse. So, we got the two sides. So, let me draw the triangle and I marked the triangle as A here, not yes, A here, B here, C. So, this is the angle given, and opposite side is the BC, this is 1, and hypotenuse is root 3. So, let us find out the AB side using the Pythagoras theorem. So, AC square equal to AB square plus BC square. So, I substitute the value, and so root 3 and root cancel out. So, 3 here, AB square plus 1, if it comes to other side 2, AB square is 2. So, AB is, sorry, I am extremely sorry, this is tan A opposite by adjacent, sorry for the inconvenience. So, opposite by adjacent. So, the values goes most here, root 3. So, AC square equal, for AB square root 3 square plus BC square 1. So, now it is cancel out 4, 3 plus 1 4. So, AC is root 4 is 2. In the next step, I just found out all the ratios, sin A, cos A, what are the ratios we needed for this problem, I just found out. I hope you saw. So, let us substitute the value in the first question. For sin A cos C, 1 by 2 into 1 by 2, these two, plus cos A sin C. So, root 3 by 2, sin C is root 3 by 2. So, let us multiply these two. So, 1 by 4 plus these two, let us multiply. So, 3 by root 3 into root 3 is 3. On the denominator is 4. So, 4 is the common denominator now. So, 1 plus 3 equal 4. If we cancel out, the answer is 1. Let us do the same to the second question, cos A cos C minus sin A sin C. So, here what I have done here, I just substituted the value. So, 1 root 3 by 2 2s are 4. Here also 4 is the LCM. Root 3 minus root 3 is 0. Next, let us try to do the 10th problem. So, in triangle PQR, right angled at Q, PR plus QR equal 25 centimeter and PQ equal 5 centimeter. Determine the values of sin P, cos P and tan P. First, let us write the values, the given data. So, what are the values are given? So, PR plus QR equal 25 centimeter, PQ also given 5 centimeter. So, this is 5. So, PR and QR both together, the summation of 2 is 25. Since we do not know any one value here, I am going to assume the value x for PR. So, what will happen? This equation, x plus QR equal 25. So, now we can derive QR equal 25 minus x. So, for now this is the value for QR. So, 25 minus x. Now, we know the two sides, right? To find the third one, what we used to do? Using the Pythagoras theorem. So, the same method I am going to use here also. So, PR square equal QR square plus PQ square. So, for PR square we do not know. So, here I substitute 25 minus x for QR plus for PQ 5 centimeter. Let us consider this as a minus b the whole square. Okay. So, the a minus b the whole square equal a square plus b square minus 2ab. So, let us substitute the value. For a square 25, 25 square plus for b square here we have x square minus 2 for a 25, for b x. Next 5 square as it is, I write it as it is. So 25 square is 625 plus x square minus 50x plus 25. So we can add these two, 625 plus 25, which is 650. Let me write it to the other side. So here we have 650 plus x square minus 50x. So the other side I forgot to write the x square. So PR here, for PR we have to write x. So x square here. So here also we have x square. So the x square will cancel out. So the remaining or 650 minus 50x. If I bring the 50x to the other side, we get 50 minus 50 is turn into plus 50x equals 650. So x equal 650 by 50, then x equal 13. So what is x here? PR, right? Let's substitute the value for PR 13 here. To find the QR side, what will we do? So 25 minus, for x we found out 13. 25 minus 13 is 12. So now QR is 12 centimeter. So now we know all the three values. Here 12 centimeter, 13 centimeter, 5 centimeter. Then what are remaining to do? To find sin P, cos P and tan P. Okay, for sin P is opposite by hypotenuse, which is 12 by 13. For cos P is adjacent by hypotenuse, which is 5 by 13. For tan P, so sin by cos, which is 12 by 5. Hope you understand. Let's move on to the final questions, the 11th one. State whether the following are true or false. Justify your answer. See the first question. The value of tan A is always less than 1. False, because the sides of right angle triangle, for example, this is 60, this is 50. So it may have any length, right? So for example here, so tan A is opposite by adjacent, so 50 by 60. So here this is for example this is less than 1, it comes less than 1. So let me take this as a 80. So it may be 80 and more than 80, it is also possible. So the tan A value not necessarily always less than 1. So it can be any value more than 1. Okay, next question. Secant A equal 12 by 5 for some value of angle A. So here what is secant A? Secant A is a reciprocal of cos A, which means adjacent by hypotenuse, so hypotenuse by adjacent. So here look at the hypotenuse is the largest side, so it is possible. So for some angle, so here the secant A is always, secant A is always greater than 1. So if you look at the trigonometric table, the secant theta is always greater than 1. So here also the hypotenuse is the bigger value. So if you reduce these two, it must be greater than 1. We get the value greater than 1. So this is true for some angle. So this is true, this is false. So what will happen if secant A equal 12 by 5? Is this true for some angle? No, this is false. 5 by 12. If this is the case, 5 by 12, this is false, because secant A never be less than 1. So from the table, right? Okay, look at the third question. Cos A is the abbreviation used for the cosecant of angle A. No, this is false, because cos A is cosine A, not cosecant. Next question. Cot A is the product of cot and A. Again false. Cot A is not the product of cot and A, it is the cotangent of angle A. If cot is separated from if the cot is separated from the A, it doesn't have any meaning, hence the given statement is false. The fifth question, sin theta equal 4 by 3 for some angle theta. So this is also false. So here the hypotenuse value, so sin theta is opposite by hypotenuse, right? So here the hypotenuse is less than the opposite side. So this never going to happen because hypotenuse is the largest side, has the biggest value than the other two sides. So this is one mistake, and another one, sin theta never be greater than 1. So if you reduce this, it become more than 1 point something. So this is not possible. So the whole statement is false. Hope you understand the whole concept. Thank you so much.